Can machines think? This question has intrigued humanity for centuries, sparking debates and inspiring countless works of fiction and philosophy. This question, once confined to the realms of myth and philosophy, has evolved over time. Now it dominates scientific discourse and captures the public imagination, driving innovation and curiosity. Artificial intelligence, the quest to create machines that can mimic and even surpass human intelligence, has become a central focus of modern technology. What was once a futuristic fantasy depicted in science fiction is now a rapidly approaching reality. AI is not just a concept, it's becoming an integral part of our daily lives. From smart homes to autonomous vehicles, in this exploration we will journey through the fascinating history of AI, understanding how far we've come and where we might be headed. We will trace its roots back to ancient myths and the earliest musings on the nature of thought itself, exploring how these ideas have shaped modern AI. We will delve into the groundbreaking work of pioneers like Alan Turing, whose theories laid the foundation for the field of artificial intelligence. Witness the birth of AI as a scientific discipline, from the early days of computing to the development of the first intelligent machines. Our journey will encompass both the exhilarating triumphs and the humbling setbacks that have characterized AI's evolution, highlighting the relentless pursuit of knowledge. We will explore the astonishing capabilities of modern AI systems, from natural language processing to advanced robotics, and how they are transforming industries. Finally, we will peer into the future, contemplating the profound implications of AI for humanity's destiny and the ethical considerations that come with it. As we stand on the brink of a new era, we must reflect on the responsibilities and opportunities that AI presents and how it will shape our world. This is the story of humanity's quest to create another intelligence, a journey marked by innovation, perseverance, and a relentless quest for understanding. It's a story still being written, with each new discovery adding a chapter to our collective understanding of intelligence. It is a story of ambition and ingenuity, of hope and caution, as we navigate the complexities of creating thinking machines. Above all, it is a story that invites us to reflect on what it means to be human in an age of intelligent machines, and how we can coexist with the technologies we create. The dream of thinking machines is surprisingly ancient. This fascination with artificial beings stretches back to the dawn of human civilization, where myths and legends often blurred the lines between the animate and inanimate. Long before the advent of computers, our ancestors were already imagining the possibility of creating life through artificial means. These early stories and ideas were not just flights of fancy, but reflections of a deep-seated curiosity about the nature of life and intelligence. Our ancestors spun tales of artificial beings imbued with intelligence and agency. These stories were passed down through generations, evolving and adapting to the cultural context of their times. In Greek mythology, the bronze automaton Talos guarded the island of Crete. Talos was a giant animated by the gods to protect the island from invaders, a testament to the ancient Greeks' imagination and their conceptualization of artificial life. Meanwhile, the sculptor Pygmalion breathed life into his ivory statue, Galatea. This myth explores themes of creation and the power of human desire, reflecting the timeless human aspiration to transcend natural limitations. These myths, though fantastical, hint at a deep-seated human desire to create artificial life and intelligence. They reveal an enduring fascination with the idea of imbuing inanimate objects with lifelike qualities. This desire found expression in philosophical inquiries into the nature of thought and the possibility of replicating it in artificial constructs. Philosophers and thinkers throughout history have pondered the essence of consciousness and the potential for its artificial replication. In the 17th century, the philosopher René Descartes explored the relationship between mind and body. His ideas were revolutionary, proposing that animals were complex machines, while humans possessed a non-material soul, a concept that would influence future debates on artificial intelligence. Descartes' proposition that animals were akin to machines, while humans had a unique, non-material soul, laid the groundwork for Cartesian dualism. This dualism would profoundly influence Western thought, shaping the debate about artificial intelligence for centuries to come. This Cartesian dualism would profoundly influence Western thought, shaping the debate about artificial intelligence for centuries to come. It sparked discussions and debates that would echo through the halls of academia and beyond, influencing the development of modern AI concepts. These early myths and philosophical inquiries, though lacking the scientific rigor of modern AI research, were crucial in laying the intellectual groundwork for the idea that intelligence is not exclusive to biological beings. They provided a foundation upon which future generations would build. They laid the groundwork for the idea that intelligence is not exclusive to biological beings. These early concepts and stories planted the seeds of a revolutionary idea that would blossom centuries later with the advent of the computer age. They planted the seeds of a concept that would blossom centuries later with the advent of the computer age. As technology advanced, these ancient dreams and philosophical musings would evolve into the sophisticated field of artificial intelligence we know today. The 19th century witnessed a confluence of scientific and technological advancements that laid the foundation for the birth of artificial intelligence. Mathematicians like George Boole developed formal systems of logic, transforming logical reasoning into symbolic manipulation that could be performed by machines. Meanwhile, the Industrial Revolution gave rise to increasingly complex machines, fueling speculation about the possibility of creating mechanical devices capable of thought. Charles Babbage, a visionary English mathematician, designed the analytical engine, a mechanical general-purpose computer that, if built, would have been the first of its kind. These developments in logic, mathematics, and mechanical computation set the stage for the emergence of the first electronic computers in the 20th century, paving the way for the realization of the ancient dream of thinking machines. Section 4. The Dawn of AI, Turing's Vision, Dartmouth Spark. The birth of artificial intelligence as a formal field of study is often attributed to Alan Turing, a brilliant British mathematician and codebreaker. Turing's work during World War II, particularly his efforts in breaking the Enigma code, showcased his exceptional problem-solving skills and deep understanding of computational processes. His contributions laid the groundwork for the conceptualization of machines that could think and learn. In his seminal 1950 paper, Computing Machinery and Intelligence, Turing proposed the now famous Turing test, a thought experiment designed to assess a machine's ability to exhibit intelligent behavior indistinguishable from that of a human. This paper not only introduced the Turing test, but also delved into the philosophical implications of machine intelligence, questioning whether machines could possess minds, consciousness, and self-awareness. Just a few years later, in 1956, a group of researchers gathered at Dartmouth College for a landmark workshop widely considered the official birth of AI as a scientific discipline. This gathering, known as the Dartmouth Conference, was a pivotal moment in the history of artificial intelligence, bringing together some of the brightest minds of the time to discuss and explore the potential of intelligent machines. The Dartmouth Conference, organized by John McCarthy, Marvin Minsky, Claude Shannon, and Nathaniel Rochester, outlined an ambitious research agenda for the field. These pioneers of AI envisioned a future where machines could perform tasks that typically required human intelligence, such as reasoning, learning, and problem-solving. Their vision was bold and far-reaching, setting the stage for decades of research and development in artificial intelligence. The researchers at the Dartmouth Conference aimed to explore the possibility of creating machines that could use language, form abstractions and concepts, solve kinds of problems now reserved for humans, and improve themselves. This ambitious agenda required interdisciplinary collaboration, drawing from fields such as mathematics, engineering, psychology, and neuroscience. The Dartmouth Conference marked the beginning of an era of intense optimism and excitement about the prospects of AI. Researchers were enthusiastic about the potential of creating machines that could think and learn like humans. This period saw a surge in funding and interest in AI research, with many believing that human-level artificial intelligence was within reach. Fueled by early successes in areas like game playing and language translation, researchers believed that human-level artificial intelligence was just around the corner. These early achievements demonstrated the potential of AI and inspired further research and development. The excitement and optimism of this era laid the foundation for the advancements in AI that we continue to see today. Section 5. AI's Growing Pains, Triumphs and Winters. The early decades of AI research were marked by both significant progress and sobering setbacks. While AI systems achieved impressive feats in limited domains, such as proving mathematical theorems and playing checkers, they struggled to generalize their knowledge to broader contexts. The limitations of computing power and the lack of sufficient data hampered progress, leading to what became known as AI winters, periods of reduced funding and diminished enthusiasm for the field. Despite these challenges, AI research continued to advance, laying the groundwork for future breakthroughs. New approaches emerged, such as expert systems, which attempted to capture and codify human expertise in specific domains. These early expert systems demonstrated the potential of AI to solve practical problems in areas like medicine and finance. The history of AI is a testament to the cyclical nature of scientific progress. Periods of rapid advancement are often followed by plateaus and setbacks, as researchers grapple with the inherent complexity of intelligence and the limitations of existing technology. Section 6. Machines that think. ELIZA, Shaky, and the quest for expertise. The quest to create intelligent machines led to the development of a diverse array of AI systems, each pushing the boundaries of what computers could do. ELIZA, a program created by Joseph Weizenbaum in the 1960s, used simple pattern matching to simulate human conversation, astonishing users with its seemingly human-like responses. Shaky the robot, developed at Stanford Research Institute in the late 1960s and early 1970s, represented a major milestone in robotics. Equipped with a television camera, rangefinders, and a rudimentary reasoning system, Shaky could navigate a room, plan its movements, and interact with its environment in a limited way. These early AI systems, though primitive by today's standards, captured the public imagination and fueled speculation about the future of intelligent machines. They demonstrated the potential of AI to not only perform tasks that were once thought to be the exclusive domain of humans, but also to interact with humans in increasingly sophisticated ways.